Okay, welcome to our next section, 1-2, the angle addition postulate. Now, when talking about angles, I first want to talk about how do we label an angle. Well, let's say I just drew this angle right here, and I said, okay, you know what, this line will be A, and here we're going to have B, and here we're going to have C. Well, we simply draw a little symbol like this, and we start with the letter A. We go A, B, C. So here we're saying angle ABC. You'll also notice that B is our middle letter, and we always call this the vertex. It's the point where these two lines meet. And you can see that very, very clearly here. B is the vertex of this angle. Now, when talking through angles, we actually have two special cases. So here's going to be our special case number 1. We have, let's say A, B, C. And you should notice that these two lines are in fact perpendicular. They form a right angle, or 90 degrees. And then let's draw a ray going through there. And what I'll do is this. I'll give this one little arc here, and I'll give it the number 1. And here I'll give this 2 arcs, and I'll give it the number 2. So how could we write this as a statement? What we're saying is this. We're saying that angle 1 plus angle 2. So if you take these two parts and add them up together, it should equal 90 degrees, because we know a right angle is always 90 degrees. Now this has a special name. We call this complementary. And this is going to be one of our key words for the day. Complementary, it means to add up to 90 degrees. And in fact, we could even have more than 2 angles. We could have 3 angles, 4 angles, 5 angles. So long as they all add up to 90 degrees, they are complementary. Let's talk about our special case number 2. Just kind of block this off. Special case number 2. What if I have a straight line, and I have 3 points on here, A, B, and C? You could even recall that's collinear when we have 3 points on a straight line. But a straight line, you might not know this, is also an angle. In fact, we call it a straight angle. And so how many degrees are there on a straight angle? Well, there's going to be 180 degrees. And what if I drew a ray coming off of this, and I gave this the point D? What could we say? Well, we could say this. Instead of labeling this 1 and 2, I could actually say angle A, B, D. And in fact, let me use a different color to really drive it home. Angle A, B, D. So it's this portion right here. So angle A, B, D plus angle. And notice here we have D to B to C. D, B, C equals 180 degrees. Let me even use a different color to underline that, DBC. So I go to D to B to C. And I'll use 2 arcs to show that it's different. Now, what is the special word here? Whenever 2 angles add up to be 180 degrees, they are said to be supplementary. Let's see if I can fit this in here. Supplementary. And I almost made it. I would ask you to pause this because these notes right here are so important. How do you label an angle? A, B, C. You go through their letters. The middle one is the vertex. And if they add up to 90 degrees, they are complementary. If they add up to 180 degrees, they are supplementary. Pause this. Take these notes. And now let's move on to our very first example. Alright, now let's go ahead and look at 4 distinct cases of angle addition postulates. So in our very first case, we'll notice that this angle is clearly less than 90 degrees. And that's important because you might remember this word from grade school. This is an acute angle. Now let's look at the things we know. We know that angle 1 is 38 degrees. We know that angle ABC, which is A to B to C, the whole, and I'll use that bracket to show the whole thing, is going to be 50 degrees. And we want to find angle 2. Now here's what I would say. What are we given? Are we given two parts and we're trying to find the whole? Or are we given a whole and a part and we're trying to find a part? And of course, since 50 is the whole, we can say that the whole minus the part is equal to the other part. In fact, let's call that part 1, let's call that part 2. So our whole is 50 degrees minus our part 38 degrees, and of course this will equal 12 degrees. So the measure of angle 2 is equal to 12 degrees, and it's that easy. Okay, let's look at problem number 2. Now this says something interesting. It says given ray AB is, remember what this symbol is from our first lesson? Perpendicular. AB is perpendicular to BD. What does that tell us about this whole angle? Well, it tells us that it's going to be 90 degrees. And we're also given the angle FBD is 17, so I go over here to F to B to D, and I can label this as 17 degrees. And once again, it becomes very clear we are given a whole. We want to subtract away the part to find the missing part. So our whole is 90 minus part 1 is equal to, and of course 90 minus 17 should be 73 degrees. You should always double check me, but we can write this. Oh, and by the way, we were looking for angle ABF, so we'd say angle ABF is equal to 73 degrees. Once again, I encourage you to pause this, finish taking your notes, and we'll move on to example 3 and example 4. Okay, so here's our third case, and you'll notice that this angle is actually another special case. We had an acute angle, we had a right angle, and this is greater than 90 degrees. Remember, we call this obtuse. Now when I look at this, I'm given the angle WSA, and remember S is our vertex, the middle letter. So from W to S to A is going to be 36 degrees. And I'm given from angle ASH is going to be angle of 103 degrees. And one other thing that I really want to stress, when I use one arc here and I use two arcs here, I'm distinguishing that these are definitely not the same angle. Now let's think back to our angle addition postulate. We know that the part plus the part is equal to the whole. And how would you label these two angles? Are they parts or are they wholes? Well, this is clearly a part, that's a part, and we are searching for the whole. So we can simply say 36 plus, let me write that just a little bit better, 36 plus 103 is equal to the whole, and we know that 36 plus 103 should be 139, which would actually be our missing angle, and I'll even write this, that's going to be angle WSH, or the whole thing. Alright, let's look at our very last example, example number 4. Now notice I only give you one piece of information. I say BIC, this angle right here is 162 degrees, and I'm asking you to find this angle CIL. So what are we going to do? Well, wait a second. We know that when we have a straight angle, this will always be 180 degrees. And so now that I know the total of my straight angle is 180, we can simply do the whole minus the part is equal to the second part, and of course this winds up being 180. I'm going to write this vertically for space. 180 minus 162, which will of course give us 18 degrees. So what is the angle CIL? It is 18 degrees. Alright, I hope these 4 examples help you out, and I'll see y'all in our very next video.